on to question 5. Question 5 says, in the diagram, the graph of f of x is equal to log of x with a base of a, and g are drawn. Graph G is a reflection of f in the line y is equal to x. Okay, so we have the log graph of it, then we have the exponential graph of that. And so because they said it's a reflection, it's really just the inverse of that graph. Okay, then they tell us that graph f passes through the points P, which is 4 and 2, and Q is the x-intercept of f, and R is the y-intercept of G. Okay, so they're just naming points that we have there. The first question, 5.1, says, write the coordinates of P prime, the image of P on G. Okay, so that's just the image of P on G. Remember that this is a reflection of this through that line y is equal to x. So it's the inverse of it. Since it's the inverse of it, when you're looking at this graph and looking at that graph, what changed is all they did was they swapped the x and y values. Okay, so to find the image of P on this graph, you would just swap your x and y values because it's the inverse. That's what happens with inverse functions. So P prime would actually be 2 and 4. And that will be your coordinate that you have here. So P prime is 2 and 4. Okay, moving on to the next question. Question 5.2 says, show that A is equal to 2. So let's look at that. Let's find A. So where did they mention A? They mention it in f of x. So f of x is equal to log, and we have x with a base of A. So let's go ahead and write that. So since we know f of x is log, we have A as a base. How do we find out that A is equal to 2? Well, this equation is almost complete. The only thing missing is the A. So it means that we just need one point to be able to find it. So be careful. Make sure you take a point that lies on F. So let's look at the graph. On F, we have a point P, which is 4 and 2. So let's go ahead and substitute 4 and 2 into this equation. So the y value is 2 is equal to, we have log, our base is still A, and the x value is now going to be 4. Okay, so now that it's in this format, we can actually put it back in exponential format so that we can solve for this, because we can't actually use the calculator for this since this is A. So this is how to put it in its proper format. First of all, you can think about what the base is. Remember, I kept calling this base, okay, base A. So that is your base. Your base is that number there. We're going to say that is A. But now A is being raised to the power of what? A is raised to the power of whatever this log function was equal to. Okay, so that's how that works. The logarithm graph really just makes the exponent the subject. So it's A to the power of 2, and then is equal to the number that the exponential function should be equal to. The exponential expression is 4. Okay, so that's how it works. That's your base, that's your exponent, and then that's the number it is equal to. Okay, now when we look at this, this is actually a quadratic equation because it has A squared. So naturally you would think, oh, okay, we can just square root both sides, which is true. You can do that. And I know normally we would consider the plus or minus, but please note we are speaking about exponential functions here. In exponential functions, we don't have negative bases. And I know that sounds weird. It's like, why don't we have negative bases? But we don't. And the reason why is because if you have a negative base, okay, let's say you have something like negative 2 to the power of, let's just try two numbers quickly. Negative 2 to the power of 1. And let's try negative 2 to the power of 2. And then you see what's going to happen. Let's also just include a third one. Negative 2 to the power of 3. Negative 2 to the power of 1 is negative 2. Negative 2 to the power of 2 is positive 4. Negative 2 to the power of 3 is negative 8. You see what's going on here? This is not going to draw an exponential function. It's going to be a zigzag function. Okay, so you're going to have like negative 2, 4, negative 8, and then something else. It's going to be a zigzag function. And that's why in exponential functions, the base is never negative. Okay, so that was just a little something I just wanted to throw in. So we're already just going to tell them that A is just equal to positive 2. And there we go. And that's our answer. Okay, moving on to the next question. Okay, 5.3 says, write down the equation of G in the form of y is equal to. Okay, so the equation of g. Remember they told you that this is f, the log, and then g is the exponential. So they want you to write down the equation of g. So since it's in the form of y is equal to, well, either ways, we would start with y is equal to, and let's just get our log function, the only one they gave us. They only gave us this. We're going to work with this and get it to g. It's inverse. So that is log, and we have the value of a now. It's 2 and x. So step 1, in order to find g, which is the inverse of f, you're going to swap your x and y values, meaning in place of y, I'm just going to replace that with x. And then I say log base 2, and in place of x, I replace that with y. Okay, so now at this point, we have to make y the subject. So those are the only 2 steps. Swap x and y, make y the subject. That's all. Now, the only way to put y as your subject is to put this back in exponential form. Okay, so I'm going to go ahead and look at where my base is. My base is 2, so 2 is my base. And remember what the exponent is supposed to be? The number it's equal to, because the log graph always makes the exponent your subject. So we have x there, and then what is it equal to? It's equal to the y. And there we go. That is our equation of g in the form of y is equal to. Moving on to the next question. Then 5.4, we have t is a point on f in the first quadrant where TR is parallel to the x-axis. And we need to calculate the area of triangle RTP prime. Okay, that's specifically P prime. Okay, let's get the graph down and see what they're talking about. Okay, let's start off with what they told us at first. They first said T is a point on F in the first quadrant where TR is parallel to the x-axis. So there's this point T, and it's going to lie on the graph of F. But also, they also told us that TR must be parallel to the x-axis. So when you join T and R, they will be parallel to the x-axis. Lines that are parallel to the x-axis are horizontal lines. So it means that to draw that line or that point, you could really just do this. It's going to be a line. And so because this line is parallel to the x-axis, T is going to lie here on that line. Okay, that line does not look very, let me just fix that. Okay, so it's going to lie on here, and that is our T. So TR is parallel to the x-axis. Then what else do they say? Okay, so then they also tell us, they ask us to calculate the area of triangle RTP prime. So remember that P prime was somewhere here, but I'm starting to see that it's probably going to be here. It depends. It really just depends at the end of the day on where this is. Now, I could estimate where P prime is. I'll just put it here so long. And the reason I'm now thinking about it is because if I put it like too close, it's going to change the shape of this triangle. And if I put it too far, it's also going to change the shape. So I'm going to just put it anywhere for now. P prime, let's just say that was here. And remember, it was just 2 and 4. We will figure out where exactly it is, because remember, these are not drawn to scale. So just because something maybe looks like a right angle triangle, it doesn't necessarily mean it is one unless they show you, some indication that, yeah, we have a right angle. Okay, so let's figure out how to actually draw this. Since we have this line already, and we know it's supposed to form a triangle eventually with that point, let's think about what T is going to be. Now, right now we don't have any other information about T other than the fact that this is parallel to the x-axis. However, if this is parallel to the x-axis, it means it's a perfectly flat line. So it would mean that the y value of R and the y value of T are the exact same thing. See? Because whatever number is here, that y value is also going to be the y value of your coordinate T. So the first thing would be, let's find R. Now in this case, R is easy to find because your equation is just y is equal to 2 to the power of x. Nothing has been added here. It's not plus 3 or anything. It hasn't been shifted to the left or right. Additionally, we can also see that the asymptote, because the exponential function, we're supposed to have a plus q here. Because there's nothing here, it means that your asymptote is 0. So here's the thing. If you have an asymptote of 0, and we have not added anything to the x, by default, it would mean that the first intercept, the y-intercept, is going to be 1. That's something that you're going to notice with these graphs all the time. You can calculate it if you want, but it's going to be 1. So now we know that r is 0 and 1. And so that would mean that t, its coordinate, is something and 1. Okay, so we know the y value now. Since we know the y value, we can actually find the x value, because this t lies on the graph of f. And because it lies on the graph of f, we can substitute this y value of 1 to get our x value. So let's go ahead and do that. So we take the graph of f, which, if you remember, is this with the 2 there. Okay, so this is our graph of f, and we are going to go ahead and substitute the y value of 1 to find our x value. So our y value is 1, which is equal to log, and we have a base of 2, and we have x. Now to solve for x, you have to put it in exponential formats because the calculator cannot do this for you. So we're going to go ahead and say our base is 2. And then our exponent is whatever number that is, which is 1, which is equal to x. And so now we can see x actually is equal to 2. So I didn't want to make assumptions. That's the whole thing. So we know the coordinate of t now. The coordinate of t is actually 2 and 1, which is great. And the reason I say this is great is because now you see that this is 2. The x coordinate is 2. Do you see another point with an x coordinate of 2? That will be P. So now I know exactly where P is. P is actually just perfectly in line vertically with T. So it's 2 there. Okay, so that's 2 and 4. That's what we have there. And now if you join this triangle, you actually get a what type of triangle there? You're going to get a right angle triangle. And that is a right angle triangle because you can see that they have the same x value, so they're perfectly in line. This is a vertical line, really. And this line is parallel to the x-axis, making it a horizontal line. Therefore, you have a right angle. Okay, because we have a right angle triangle, we just have to now find the area of this triangle. They asked us to find the area, and we can use the rule 1/2 times the base times the height. That's what we can use. So I'm saying the area of triangle RTP prime is equal to 1/2 times our base times our height. So we just have to find the base and the height. The height is going to be super easy to find, and also the base, because this is a flat line. So we don't need to use any distance formula. Here's the reason I say so. You see that the base, this line, is going from, the x value is 0, and it's going from this point 0 all the way to 2. So how long is the base? It is 2 units, literally 2 units, 0 to 2. That's it. And then the y, we can also find that easily by saying, since this is a vertical line and this y value is 4 and this y value is 1, then just say the difference would be your height, meaning just say 4 minus 1, and that gives you that distance over there, and that's going to be 3 units. So there, our base is 2, our height is 3. Okay, remember this is not Euclid, so you don't need reasons. So we're saying 1/2 multiplied by our base of 2 multiplied by our height of 3. And I'm just going to go ahead and say 2 times 3 is 6, and then 1/2 times 6 is 3. So our area is 3 units squared. Okay, remember that is the measurement of area. So that is our answer for that question. And that is the last question in question 5. So we finally move on to question